Hi everyone, this is Mrs. Torigno, and this is the last video for the Chapter 6 test review for Algebra 1B. This video will cover questions 27 through 32. So, 27 gives us a graph to look at, and the graph represents the height of a baseball thrown upward as compared to the time, which is t. So you've got time here, you've got height here, and this is your baseball. Okay. First question says, when does the ball reach its maximum height? So the way I sort of approach one of these questions is first I figure out what place on the parabola are they looking for. If they are looking for the maximum height, that means they're talking about the vertex. That's where the maximum is going to be. And so I'm looking for this point here. And then the question says when. So I need to think about, is that my x-axis or my y-axis? The x-axis is time, the y-axis is height. So I ask myself, which one of those axes would answer my question? If the question is asking when, that means I want to know the time, okay? And if I'm looking for time, that means I'm looking along the x-axis. So I'm going to go from that vertex point and draw a line as close to straight down as I possibly can. And it looks right about 1 second, maybe a little bit past 1. They didn't really give you grid lines here, so it's hard to tell. I would take any answer that's right around 1 second. So if you said like 1.1 second, 1.2 seconds, that would be fine too. Okay, you're just estimating from the graph. Now, letter B is also asking about the maximum height, so that's still talking about the vertex. But this time the question says, what was the maximum height? So I'm answering that with a height, not with a time, which means that I'm still looking at the vertex, but I want to look at the height instead of the time. Okay, and I would say that's right about 20, this is in feet, right? Yep, 20 feet. It's maximum height of the ball, 20 feet. Okay. How high was the ball at 2 seconds? So again, I noticed the question is saying how high. That means I'm looking for a height, which means I'm looking for something along the y-axis. Okay, because the y-axis is my height. And then I'm looking at 2 seconds, which must be my t value. Okay, so this is telling me I want to find 2 seconds on the graph. Read straight up and go straight across. And let me do that with the pen here. So from 2 seconds, I'm going straight up, finding where that hits the graph, and then reading the height. And I think if I did that correctly, if those lines are straight, that it's right at 10 feet. Okay. The next question says when. So when means I'm looking on the x-axis because it's the time. When was the ball 10 feet high? So 10 feet high, that's an h value, which is on my y-axis. So actually, one of my answers was right up above in part C. If this is 10 feet right here, I want to know when am I at that level. And hopefully you can see that there's actually 2 places that you would be at 10 feet. Because you're going to be there once as the ball is going up and another time on its way back down. So here, I would say that's about 0.5 seconds. And again, if you round it a little differently, that would be okay. And then the other one we just found should be at 2 seconds. Because didn't we just say that at 2 seconds we were at 10 feet? So we were at 10 feet at 2 seconds. It's just asking the same question backwards. Okay? So that's how you would answer something like that off of a graph. Alright, let's take a look at 28. Suppose a rocket is launched with an initial velocity of 225 feet per second from a platform 3 feet high. Write an equation modeling the height of the rocket as a function of time. I know that sounds really intimidating, but remember what this is really getting at is Newton's formula. Okay, and the formula for Newton's looks like this. negative 1/2 gt squared plus v sub 0 t plus h sub 0. Okay? So that means h equals negative 1/2. Now for g, remember g represents the gravitational pull, or the acceleration of the object due to gravity, which is going to be the same all over the planet. Okay? So normally we would just fill this number in for you, except the number that you use changes based on whether you're using feet or meters to measure. Okay, it's kind of like 24 inches and 2 feet. It's the same distance. Okay, 24 inches and 2 feet is the same distance, but just different units of measurement, so I'm using different numbers. In this case, my question is being measured in feet. Okay, I see feet here and I see feet here. So that means that my g value is 32. The t just stays a t. It's like your x value. Okay? Plus the v sub 0 stands for your velocity. Okay, and that's given to you explicitly in the problem. So 225 t plus, and the h sub 0 here is the height that you're starting at, which is 3 feet. So plus 3. And I would probably simplify this a little bit and say negative 16 for negative 1/2 times 32. Okay, there's your equation. Negative 16t squared plus 225t plus 3. Okay, next question says, when will the rocket reach its maximum height? So thinking back to what we just did a second ago, maximum height, that's talking about the vertex. I'm going to kind of write over what I already have here, but maximum height is talking about the vertex, because that's the top of the parabola. Okay, so if I'm looking to do this mathematically, now you can do this on your calculator too, but if you're looking to do this mathematically, I need to do something that would find the vertex for me. Okay, which means I need to find h and k. Okay, I'm going to be throwing a lot of letters at you here, but try to follow me. And the question just wants to know when. Okay, so when is your time, which is like your x value. Okay, so you really only need the first number of your vertex, because that will answer the when question. Okay, if I wanted to know how high the ball would actually go, I would have to find that second number of the vertex. Okay, because the second number is your y value, which tells you how high the object is. Luckily for us, we just need to find the first number, which we can do with the little formula, negative b over 2a. And if I'm looking at this equation that I just wrote, b would be 225, so this would be negative 225 divided by 2 times negative 16. So really it's negative 225 divided by negative 32, which I believe, if my math is correct, comes out right about 7. Okay, it's like 7.03, something like that, but we can go ahead and round to the nearest whole second, because we're just asking when will it reach this height. So I would say at about 7 seconds it'll reach its max height. Okay. Next question says, how high? Okay, so if it's asking me for a height, that's really asking me for like the h value or the y value of this equation. Will the rocket be after 6 seconds? I guess I should put, not that that's y, but that it's asking me to find h, and it's giving me a time, meaning it's giving me a t value. Okay, so I want to know, what is h equal when t equals 6? And that's pretty easy to figure out. I just have to take that 6 and put it in for t. So negative 16 times 6 squared plus 225 times 6 plus 3. And when I do that, I end up with 777. And that's a height, so that's in feet for my answer. Okay, so at 6 seconds, I'm at 777 feet. Now the last question. At what times? So it's asking me to find, if it's asking me what times, that's a t value or an x value. Will the rocket be 75 feet off the ground? So this 75 feet, that's a height. Okay, so this time it's asking me to plug in an h value and find a t value. Okay, I'm going to do this in a different color, actually. So t, this is our h. Okay, and so here's what that's going to look like. I might move off to the side for this one because this one's going to be a little bit messier. My h value is 75. So I'm putting 75 in place of h. Looking back at my equation way up here at the top, 75 is going right here. So I have 75 equals negative 16 t squared plus 225 t plus 3. And I'm trying to solve for t. So think back to how you solve one of these. It would be great if I could solve with a square root, okay, which I would need to get rid of the t squared, or to get rid of the square so that I just had the t. But look, this is a problem that has a t squared and a t. So I'm not going to be able to just do a square root. This is going to require the quadratic formula. And the way I would do it is I would subtract 75 from over here on this side so that I can get my t value alone. Okay. And so here's what my equation is going to look like when I do that. I would end up with 0. Again, I'm subtracting 75 from each side, plus 225t, and then I had 3 and I subtracted 75, so now this is negative 72. And now I'm going to launch into the quadratic formula. Okay, so for the quadratic formula, negative b would be negative 225 plus or minus the square root of 225 squared minus 4 times negative 16, oh boy, times the c value, which is negative 72. Okay, so b squared minus 4ac all over 2a, which is 2 times negative 16. Okay, this square root part, when I type that into my calculator, looks like I get, I think, 214.2, 214.5. Sorry, I'm looking at my answer key I prepared previously. So negative 225 plus or minus 214.5. And then on the bottom, 2 times negative 16 is negative 32. Here's where I'm going to split. And first I'm going to kind of shorten this up because it's not all going to fit. Negative 225 plus 214.5, okay, divided by negative 32. And when I do that, I'm going to end up with, oh, let's see, negative 10 like negative 10.5 over negative 32, which comes out to be 0.328, and remember this is a time, so that's second, because what I'm really solving for here is t. I know I wrote an x here because that's what you're used to seeing with the quadratic formula, But remember, in Newton's formula, we use t instead of x. So that's what I got when I did negative 225 plus 214.5. Now if I do negative 225 minus 214.5, that's going to give me negative 239.5 divided by negative 32, which when I divide that, I end up with 13.734. Now, does that make sense for there to be two answers? Yes, it absolutely does. Because, whoops, it's not letting me move it to draw down here. But remember, this is a parabola that looks like this, okay? And I wanted to know at what times will I be 75 feet off the ground. So let's say that 75 feet is here, okay? You would be at 75 feet here, and you would be at 75 feet here. So here's your first answer, and here's your second answer. Okay? So to do that one mathematically is a little bit tough. That one might be a little bit easier to plug into a calculator. Oh, all that stuff's going to be in my way. Okay, clean start here with number 29. I.M. Chisov of the USSR set a record in January 1942 for the highest altitude from which someone survived after bailing out of an airplane without a parachute. He bailed out at 6,700 meters. So write an equation describing his height describing his height at t seconds. Okay, so again, I'm going to use Newton here. So it's going to be negative 1/2 times g, which in this case, because I'm measuring in meters, I'm going to use 9.8 t squared. Now for this one, the initial velocity, because there was no force behind him, he wasn't being shot out of a cannon or pushed out of this plane. Okay, he just went out without a parachute. My velocity at which I left, we're going to say is 0. Okay? He didn't leave with any force, with any outside force behind him. And then the initial height is the height at which he jumped, which was 6,700 meters. Just to clean that up a little bit, really 0t I can cancel out, and I can put together the negative 1/2 and 9.8. So I'm going to rewrite this equation as h equals negative 4.9 t squared plus 6,700. Okay, that's my equation. Negative 4.9 t squared plus 6,700. Then it said, about how long did his fall take? Well, if he fell all the way to the ground, that would mean that I'm looking for the time, because it's asking how long, so I want to know the time when the height is equal to 0. Okay, because I'm looking for, if he's on the ground, if I want to know how long until he landed on the ground, at the ground level, my height is 0. So I'm going to put a 0 in for h and try to solve for t. I would say 0 equals negative 4.9 t squared plus 6,700, and solve. Now, I certainly could use the quadratic formula like I just did in the last problem, okay, but because this problem only has a t squared, it doesn't have the other t in it, I can solve it just like a regular equation. I could subtract 6,700, I'm going to move off to the side again here. So I would end up with negative 6,700 equals negative 4.9 t squared. Let's divide by negative 4.9. Okay. And I end up with 1367.35. And over here, my 4.9's cancel out, so I'm left with just a t squared. Take a square root, take a square root. And I am left with t equals plus or minus, because remember when you take a square root you have to do plus or minus. Let's see. Comes out to an irrational number, and it's like 36.978-ish if I round it off. Now, that's the mathematical answer. I want you to think about, does it make sense to have a negative time? Okay, because what I just found was the time at which you would land on the ground. It wasn't 36 seconds ago. It's positive 36.978. And since I'm talking in seconds, let's just go ahead and round to the nearest whole second. So I'm just going to say 37 seconds. So mathematically that negative answer makes sense, but practically it does not. Okay, one more on this page. The terrific Torigno Pizza Parlor wants to offer the medium pizza in two different ways, round and square, which is really a rectangle. I want you to look at the pizza you get next time you order a square pizza, okay, and tell me if it's really a square, because it's probably not. The prices are going to be the same, so we want to make sure that the pizzas have exactly the same area, or at least approximately the same area, so no one is getting gypped here. Okay, the dimensions of the square pizza are 10 inches by 11 inches. So let's draw some pictures. Here's my quote-unquote square pizza, where this is 10 inches, and up at the top it's 11 inches. And then I'm also going to have a round pizza, and I don't know the radius of it yet. That's what I'm trying to find out. Okay, but I want the two pizzas to have about the same area, which clearly from my picture they do not, but they're supposed to. Okay, and I'm trying to find out what the radius would be to get these to match. And again, what I'm comparing here are the areas. So I need to think about how to find the areas of these pizzas. Area of this pizza is 10 times 11. Area of this pizza would be found by doing pi r squared. Okay, so 10 times 11, that's 110. And I know that that has to equal pi r squared. And what I'm trying to find is the r value. So let's solve for r. Okay, I would start by getting rid of that pi. So let's divide by pi. And you can just use 3.14 for pi. Let's see, 110 divided by 3.14 comes out to 35.03. Equals r squared. And now to get rid of that square, we're going to take a square root. And when I do that, again, this is another one where technically I should say plus or minus in my answer. And I get like 5.99 for r. And let's just go ahead and round that to a whole number because it did say approximately. Okay, what should the radius be? So 5.99, I'm pretty comfortable with calling that 6. So we want our radius to be 6 inches. Okay, in order for the two pizzas to have about the same area. Okay, technically this would give you, if we round, since we rounded from 5.99 up to 6, the round pizza would give you slightly more pizza for the same amount of money, but, you know, who's really counting? Okay, let's head over to the back. Okay, the questions on the back here are pretty open-ended. It just wants you to tell me about this parabola, but I've given you some specific things that I want you to look for. I want you to look for the vertex, the x-intercepts, what direction it opens, what the axis of symmetry is, and how wide the parabola is. So I'm going to list it here in bullet points just because that's easier for me writing on the iPad than it is to write it out like in a paragraph form, but I would expect your answer to be in a paragraph. If you need an example of that, the answer key I have posted online, I wrote a really solid example for both of these for how to write this paragraph. Okay, so I'm just going to kind of identify some key points here. Okay, the coordinates of the vertex. Remember, this equation here is written in vertex form. So my numbers for my vertex are the h and the k. All right, if I line that up next to vertex form, here's what that looks like again. Y minus k equals a times x, whoops, x minus h squared. So I'm taking my k value and my h value, and remember, because there are minuses in the equation, they're going to be the opposite. of what they look like in the equation. So my vertex for this parabola would be at -1, -8. Okay. I'm going to skip number and location of x-intercepts for now. We'll come back to it in a minute, but from this form it's pretty tough to get that. So let's talk about direction of opening and the width, because both of those are found by looking at the a value, which is 2. A equals 2. Because it's positive, that would tell me that my direction of opening is up. That was really confusing the way I just wrote all that. Okay, because my a value is positive, that tells me that my parabola is opening up. Because it's bigger than 1, that tells me that my parabola is going to be skinny. Okay, so those are the next two things I'm going to add to my list. Okay, that this parabola opens up and is skinny. Both of those things come from the a value. Okay. And I guess really right after vertex I could have jumped straight into axis of symmetry. Remember, axis of symmetry is a vertical line, so it's going to have an equation that's x equals, sorry, I'm kind of making this up as I go in terms of how I format this, but the axis of symmetry is always going to be an x equals equation, and it always equals the x number from the vertex. So your axis of symmetry is just x equals -1. Okay? And now the last piece of it, the number and location of x-intercepts. So remember, there were some problems earlier in this packet where it was asking you how many x-intercepts does this problem have, or does this equation have. To find that, you need the discriminant. But to do the discriminant, you've got to be in standard form. Okay, which means I need to take this equation that's written in vertex form and simplify it. Okay, and that's why I was saying this is a little more complicated. So let's simplify. This is really kind of pulling everything together that you had to learn in this chapter. Equals 2 times x plus 1 times x plus 1. I'm going to FOIL those together, so I get y plus 8 equals 2 times x squared plus 2x plus 1. Distribute my 2, so y plus 8 equals 2x squared plus 4x plus 2. And then I would subtract 8 from both sides and get y equals 2x squared plus 4x minus 6. Okay, so I've got to do that before I have any hope of figuring out how many x-intercepts I have. Okay, once I've got that, now I'm going to look for the discriminant. Okay, discriminant is b squared minus 4ac, so 4 squared minus 4 times 2 times 6 is 16 minus 48. Oh, I'm sorry, that's a -6. Okay, so 16 plus 48 is 64. Okay, and so because that's positive, that tells me that I'm going to have 2 x-intercepts. And now to figure out where they actually are, I'm going to have to go back to my regular quadratic formula. Gosh, I'm running out of colors here. So quadratic formula, I'm going to say x equals -b, and here's my equation that I'm looking at. So -4 plus or minus the square root of 64 all over 2 times a, which is 2. So that's going to be x equals -4 plus or minus 8 over 4. -4 plus 8 is +4, and 4 over 4 is 1. So I could say my 2 x-intercepts are at, x equals 1, and, Okay, my other one would be negative 4 minus 8, which is negative 12, and negative 12 divided by 4 is negative 3. Okay, so those are my x-intercepts there. Again, I was asking you to write it more in a paragraph form, but these are the important pieces that you're going to want in your answer. Okay, let's take a look at 32. 32 is asking me the same questions, except this one is in standard form. Okay, so for this one, I'm not going to have to do, I'm going to bring this back down a second. I'm not going to have to do all of this, okay, because this one is already in standard form. I still will have to do this stuff, but I won't have to do the simplifying. However, the vertex is not as obvious because I'm not in vertex form. So I'm going to have to do some solving to find my vertex. That's okay. It's not bad. To find the vertex, let's find h, which is negative b, which in this case would be positive 5, over 2a, which is 2 times negative 1/2. Okay. That's 5 divided by negative 1, because 2 times negative 1/2 is negative 1, so my h value comes out to be negative 5. And then to find k, I'm going to plug that negative 5 in for x. So negative 1/2 times negative 5 squared minus 5 times negative 5 minus 12 comes out to be 0.5. So my first point that I can mark down is that the vertex is at negative 5 and 0.5. Okay. I'm going to jump right to axis of symmetry, which is probably what I should have done last time, because axis of symmetry comes right from the vertex. Axis of symmetry, remember, it's going to be an x equals, and it's just always going to be the first number from the vertex, so x equals negative 5. Okay. Then I'm going to look at my a value, and I do still have an a value. It's not written in vertex form, but my a value is still negative 1/2. So because that's negative, this one is going to open down. And then I ignore the negative sign and look at just the value of the number, which is 1/2. And 1/2 is larger than 1, so it's going to be wider than average. Okay. And then I need to know how many x-intercepts and where are they. Okay, so I will still have to use the discriminant. Okay. But I can just jump straight to finding the discriminant. It would be negative 5 squared minus 4 times negative 1/2 times negative 12. Let's see, that's going to be 25 minus 24, I believe. Yep, 25 minus 24, which is 1. That is positive. Okay, so I'm still going to have 2 x-intercepts. Now to find where they're actually at, let's go back and use the rest of the quadratic formula. So negative b would be positive 5 plus or minus the square root of 1 over 2 times a, which is negative 1/2. That's going to leave me with 5 plus or minus 1 divided by 2 times negative 1/2 is negative 1. So 5 plus 1 is 6, and 6 over negative 1 is negative 6. So x-intercept at negative 6. Whoops. And my other one would come from doing the same thing with the minus. So 5 minus 1 is 4, and 4 over negative 1 is negative 4. Okay, so those are all my characteristics of my parabola. And again, I would want you to write that in paragraph form, the way the question is worded. Now it says graph each of the equations above. Now, I showed you how to plug these into your graphing calculator and look for the table, which gives you all of the different coordinates for the parabola, and that would be totally fine. But look at all this information I just found out. Okay? That's probably enough to draw yourself a pretty good graph here. For example, this first one, I would start with the vertex. The vertex is at -1, -8. Oh, my old lady eyes are making this difficult. -1, 6, 8. I hope that I'm counting right, but should be right there. Okay. I know that my x-intercepts are at 1 and -3. So I know that's where this parabola is crossing the line. And it's supposed to be skinnier than average, which if I look at this is going to be a pretty skinny parabola. I know it's going to open up, so my arrows are going to be pointing upward. Okay, so from here I should be able to just sketch a parabola. Okay, and your artwork is not critical here. Just make it look like a parabola and you're good to go. Okay, and I do also want to point out your axis of symmetry is x equals -1. So if I were to draw this vertical line at -1, your graph should be symmetric. And it is, my drawing's a little off, but like for example your x-intercept, see how this one is 2 spaces away and this one should be 2 spaces away? Okay, so I could take any point on the parabola and its distance from the axis of symmetry should be the exact same thing on the other side. Okay, just to help your picture come along a little nicer. With number 32, my vertex is at -5. I should blow this one up some. Vertex at -5, 0.5, so it's sort of halfway up. It told me that my x-intercepts are at -4 and -6. Now this one, because those points are all a lot closer together, it may be helpful for you to put this in a graphing calculator and find some other coordinates down here so you can tell exactly how to draw this. I'm just going to kind of wing it, but I know it's supposed to be wider than average, so I'm making it a little wider than it normally would be. Okay, there's what that one would look like, and it is supposed to open down. And again, my axis of symmetry is right here. So all of my other points should be the same distance away from that red line. You don't actually have to draw the axis of symmetry in. I just wanted you to see how it relates to the graph as a whole. Okay, that's it. And that was a nice way to end, because those last two problems really kind of asked you to pull in everything that you've learned about quadratics and about parabolas. Okay, so if you can handle those last two questions, you should be able to do anything else on this test. Good luck and happy studying.